Hey, what's up? It is Monday, 3/17. Now, I know we're a little bit in two different places, so I'm going to get us all back in together. So, I do want to say this, the exploration number one, and I will be posting the video for that. It should be the video before this one, and that walks through that video. That one is already posted. That assignment is due tomorrow, the 18th. Also, the potential energy math connections that was started on Friday. Some people started it today. It's okay. Either way, it is due tomorrow, okay? And so inside of this video, there will be an explanation for that. So I will splice a walkthrough for that assignment for the potential energy math connection in case you still need help inside of this assignment. So, or inside of this video right here. I do want to make sure that everyone is aware we are having a quiz on Friday. So types of energy, what is energy? What is kinetic energy? What is the law of conservation of energy? And then there will be these formulas, and then there will be the kinetic energy formula, and there will be the potential energy formula. So all of those, and what is potential energy? That will all be on the quiz. I'm hoping by Tuesday or Wednesday, I will have all of those things together. Probably by tomorrow, I will have the practice stuff up so you can start practicing and studying. But if you just know and are using these things, it should be hopefully straightforward for you. But again, start studying and reviewing. All right. Market day. If you haven't done these, we talked about this last week, but if you haven't completed these, please complete them. The links for Mrs. Borba were not working, so I got them working now, so everything's good. Again, these are in modules, so go ahead and hit those up in there, okay? Cool. On to this next one. We are having the 3-week progress report. That is going to be happening this Thursday, so you'll get the 3-week progress report. So I want you to pause the screen, and then take time to look at Canvas, Aries, and make sure you're good to go. Go through your emails, make sure you are good to go. Once you have done that, spend a little bit of time going through the actual the market day surveys, right? And please hit up Miss Borba's links because the other links already kind of got gone through for the most part. So I just wanted to put that out there. So now the rest of this video, I'm just going to make sure that some people turned a few things in, all right, and that you guys are all done with everything. So hold on, let me. Okay, so for everyone, I just wanted to go into modules real quick, and this is from last week, so make sure your journal check 11 is already done. I did most of that in class. Again, if you didn't get that done in class, please scan it, or you can come show me at some other time. So scan it and get that turned in. Rubber band energy, page 17. Make sure to get that turned in as well, scanned in. Now, some people might have 17 and 18 because when you were writing your answers, it went on to page 18. So make sure that you guys got that taken care of. And then the last thing is market day surveys 2025. Make sure that that is good. All right, the rest of this video will be about going over this assignment, potential energy math connections. I'm going to go ahead and splice in a whole tutorial video of me going through it. Also, I did want you to be aware that there is a video here that just walks through how to use the potential energy formula. So make sure that if you really need help that you can check that out. And if you're at home, here is the entire worksheet right here. You can download it as a PDF and then work on it that way, or you can just write it all out on a piece of paper. Either way is totally good, not a big deal. All right, y'all, the rest of the tutorial video will be coming at you in 3, 2, and 1. It says there's one type of potential energy, it's called gravitational potential energy. That is exactly what we've been looking at. So as it talks about gravitational, it depends on an object's height above the ground, which is often measured in meters. Okay, the pull of gravity, so gravity, which is measured in meters per second squared, which we talked about yesterday and we talked about again today, and then the mass of the object, which is measured in kilograms. So that's everything that we need. Then it's telling us what this formula represents. So it's mass times height times gravity. Sometimes it's represented in that way with the dots. I usually use the dots right there. And then mhg, which is just letting you know if there's no space in between them, the assumption is multiplication, right? Then the last thing that's really important right here is that gravitational potential energy is expressed in the energy unit known as joules. So again, right, we're going to come down here to this page right here. We're going to scroll on down real quick. And then right here, we're going to talk about units and what these things mean. So the meaning of this one is mass. So I'm going to put that in there, mass. And then its unit, and we saw that, hold on, I guess I could scroll up just a little bit. its unit is in kilograms. So I'm going to put kg. Hopefully you got that. And then this is height, right? And then its unit is in meters. And then this is gravity. And its unit, again, and I just mentioned that, right, is meters per second squared. Okay, cool. So we got all of that taken care of, no big deal. Then if we want to just throw in one more, right, if we want to just say here, and I'm just going to put this up here, is potential energy, and its unit is joules. Okay, that's one I would just throw in, right? By the way, make sure you guys got this written down on your paper, or if you're having to do this at home, you're going to have to make up your own table and then write it in there, okay? Now, an Olympian, and I'm going to show you how I read through these. So an Olympian lifts 1,375 kilograms, okay, of set of weights, vertical distance of 2 meters. Now, you see how as I'm reading, all the numbers, I know that's probably what I'm looking for, right? So I'm already highlighting, or, right, you're like, oh, I don't have a highlighter. Don't worry about that. Here we go. At a weightlifting, the force of gravity equals, so gravity is equal to 9.8. You can just do that. What is the potential energy, right? So why am I underlining what is the potential energy? Hopefully you're realizing it's because I'm like, yo, that is the actual, right? That is the actual thing that they're asking for. You cannot solve the problem if you don't know what they're asking for. So this is how I think about word problems. This goes for math. This goes for chemistry. This goes for physics. This goes for whatever. This is how I diagnose word problems. So I always highlight or underline the information. That way I don't have to be digging back through the word problem trying to figure it out. So in this case, right, what is the mass in this case? And the mass, oh, it's 1,375 kilograms. So 1,375 kg. Okay, that's this, right? Boom. So now I'm going for the height. So the height is, 2 meters right there. Okay, and then my gravity, which we know it's the Earth gravitational constant, is 9.8 meters per second squared. Okay, cool. Now, the potential energy, that's what we're going to actually calculate. So let me get my handy dandy calculator, and I'm going to use the one that y'all use. So let's see if we can go over here. Oh, I don't want to expose nobody's grades. Let's see. Nope, that's nope. Nope. Oh, I think we can't go here. Okay. That'll be cool. Go to courses. Oh, actually, what am I saying? I have it right here. Blah out. The bookmarks. I think it's right here. Yep, Desmos calculator. There we are. Bam. So I'm going to go like this. I got my Desmos calculator now. And I'm like, okay, so it's 1,375. So I'm actually, can I make this smaller? Nope, I think it's as small as I can make it. Sorry. So 1,375. I'm not putting any kind of commas or units in there. Just remember, that's how you do that, right? So then I'm just going to say multiply, and then it's 2 times 9.8. And again, I'm not putting any units in there, okay? So then my answer ends up being 26,950. So 26,950 joules. So then I'm going to go ahead and write this right in here. So I'm going to go like this and say 26,950 joules, okay? It's exactly how it should be done, okay? It's exactly how it should be done. All right, so let's look at this next one and see if we can diagnose right through it. So pause the screen, again, pause the screen, and then see if you guys can work through it, and then come back and let me know. Try and see if you can solve number 3 on your own. All right, let's get into it. Let's get into it. All right, so a child wants to reach the cookies on the top shelf of the kitchen. Doesn't sound like anything. Just let me know what's going on. The shelf is 1.5 meters high. Sounds like my height. The cookie of the jar has a mass, it tells me off top, this is my mass, of 0.75 kilograms. What is the potential energy? Okay. Of the cookie jar before it is taken off the shelf. Round the answer. Oh my gosh, round. I need to round to the nearest hundredth. So just in case you're trying to remember, see, like this right here is the tenths place, this first one. This second one here is the hundredths place, okay? That is the hundredth. So that's where we got to round to hundredths, okay? All right, now on to what we need to do. So potential energy, I know, right, is equal to mass times height times gravity. So my mass is 0.75, 0.75. So that's my mass times the height is 1.5 meters. Okay, so that's my height right there. But then what the heck is the gravity? They didn't tell me what the gravity is. But remember, we're on Earth, so the gravitational constant will always work. Okay, so that's 9.8. Oh, I don't got my point in it. 9.8 meters per second squared. Okay, so that is how I'm calculating potential energy. I'll put PE down here. And then now it's time for us to just do the math. Okay, do the math. So let me pull up this calculator. Can I not pull up the calculator? What's going on? Oh, I need my Desmos calculator. Where's it at? There it goes. So then I got 0.75. Whoops. So 0.75 times 1.5 times 1.5 times 9.8. That's my gravity. And the answer is 11.025. Okay. So let's go back to this. Okay. Boom. Sorry, we got a little out of whack. Okay, there we go. And then remember, I memorized the answer. It's 11.025. But they said we had to round to the hundredths place, which means we got to round right there, which would end up making this number 11.0. Hey, 5 or more up the score, 3 joules. Because remember, it's potential energy. And that's how you would do that one, okay? Cool. Let's go to the very next one. Now, this one is going to get a little bit crazy. I'm going to tell you right now. Now, off the top, I'm going to go ahead and do a couple of things. So, let's just read it and see what's up. So, number 4. To raise a 0.48 kilogram box from a shelf, a 6 joules of work is done. How far was the box lifted from the shelf? Round to the nearest tenth. Uh-oh. Now, what are they asking us to calculate here? This is the question, right? It says work is done. How far? So how far was the box lifted? That's what they're asking us. And then we got to round to the nearest tenth. So I'm just underlining information we need. So it looks like we have the mass. And remember, joules is potential energy. So that means we have the potential energy, and then, or we have the energy, and then we also have how far. So far is more like a distance or like the height that it was lifted, because lifted means up, so that means height. So we do not have the height, so we're solving for height. So the first thing it tells us is rearrange the formula to solve for height. Now this is where it can start getting crazy, okay? Now, here is the formula. Potential energy is equal to mass times gravity. And I'm going to put it in there just because it will help with our understanding. Times height, okay? Now, some people are like, how in the heck are we going to rearrange? Don't trip. I got you, fam. So let's just talk about this real quick. 6 is equal to 2x. How would we isolate for x? How would we solve for x? The same way we want to solve for h, we got to solve for x. So everyone's like, oh, divide by 2. And whatever you do to one side, you got to do to the other. All right, cool, for sure. So then I'm going to cancel both of the 2's. Now the x is by itself. 6 divided by 2. Hopefully you're like, oh, that's 3, right? So then x equals 3. Now some people are like, I don't like it written like that. That's fine. So we're just going to put x equals 3. Okay? These are the same, though. So it's no big deal. So in the same way that this is how I solve for x, I'm going to solve for h, okay? So this is what I want to get by itself. So since g is multiplied right here, then I can divide by G. Also, just like 2 is multiplied to X, well, G is multiplied to H. Again, we're just applying the same logic and the same math. Now we're just applying it to the variables or the letters, so that way when we go to solve, it's going to be that much easier. And since M is also multiplied, then I can go ahead and divide by that. Now look, cancel, 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 cancel. But whatever I do to one side, I have to do to the other. Times, right, mg. That's what I had. So then, right, and I'm going to make it so that you guys feel comfortable. H, I'm going to take my H on one side of the equal sign, say equals. Here's everything that H is equal to over here, which is potential energy, right, divided by mass times gravity. And just as a reminder, I'm going to put the parentheses to help with the order of operation, because multiplication comes before division, okay? So now that we have our formula here, let's just plug everything in. So H, and then our potential energy is 6 joules. So we're going to put that 6 joules on top, because that's what we see right here. Okay, and then divide it by the mass, which is the 0.48. Okay, again, I'm going to put parentheses 0.48. Okay, kilograms, times the G, which is the gravity. So that's the 9.8 meters per second squared. And I'm going to go like that. Boom. And I got that. So now, if you look, again, potential energy, mass, here's the mass. Gravity, there's the gravity. So now, let's go ahead and get that done up in there, okay? Let's go. Let me move this over to this side. Now watch the way I'm going to put this in. You got to click that return button, okay? So I'm going to put 6, and then I'm going to say divided by, and then in the same way I have this parentheses, I'm going to go ahead and put a parenthesis right there. Boom. Then I'm going to put 0.48 times, and then times my 9.8, 9.8, and I'm going to put a parenthesis. Boom. Just like I have there, just like I have right here. And then my answer is 1.2, right? So the answer is this. Here's the answer. Oops. Ooh, I need it back. 1.27. It had a whole bunch of numbers, right? A whole bunch of numbers. Okay, 1.2755. Oh my gosh. And there's a whole bunch of more numbers, right? So I'm going to need to, I'll put the 5 and the 5. And then it says we have to round to the nearest, right? Round to the nearest 10th. That's where it is right there. The 10th is right here, okay? So we need to round there. So 5 or more up the score. So it's going to end up being 1.3 meters, because it's asking us for height, okay? So that is our actual answer there. Okay, so hopefully that helps you out. We walked through a couple of word problems, and we've already done some things. So we'll look at some of these problems in class tomorrow, but what I want you to do is try to solve them on your own to the best of your ability. Then we'll keep going, okay? Number 6 is very similar to number 4. Pay attention to what's going on in number 5 with the apples and the cart and all those things. So that's as far as we're going to get for today. We're already at 20 minutes. All right, y'all, peace!